through the graphing quadratics function test study guide. So this video will go over 5 different topics that will probably maybe appear on your test. So I hope this is helpful, and we'll just go ahead and get started. So here's the test study guide. Our topic 1 is graphing quadratic functions from standard form. We know this is standard form because we have all of our variables already multiplied out. We have a B, and C term. Remembering that, let's see, standard form reads ax squared plus bx plus c. We have our 3 terms. If you ever don't see a term, let's say it was just x squared plus 12, and you don't see this b term, the middle term where you have your x variable to the power of 1, that means your b value is equal to 0. That means it looks like 0x, and we don't write 0x because 0 times anything is 0, so that whole term disappeared. It doesn't mean that your b value is gone. B just equals 0. So remember that when you might see a quadratic function that might look something like this one. But in this case, that's not what we have. We have all 3 terms. Our a, and let's just go ahead and write these out. For this problem, our a is equal to 1 because the number being multiplied to x squared is 1. You don't see a 1 there because it's implied, but we know it to be 1. Our b value is the number that's being multiplied to our x term. So in this case, that's 4. And our c is the constant. Don't forget that these numbers could be positive or negative. In this case, c is negative 12 because you see there's subtract 12, negative 12. To factor this, well, we've done factoring. I'm not going to explain how we factor it, but I will write the factored form. Y is equal to x subtract x subtract 2, x add 6. The way I know my answer is right is because now I can distribute this out. If I multiplied x times x, I get my x squared term. When I multiply this x by this 6, I get positive 6x. When I multiply this negative 2 by that x, I get negative 2x. 6x subtract 2x is that middle term 4x that we had here. And then the last 2 terms, negative 2 times that positive 6 makes that negative 12. So it all checked out, and we know that to be the factored form of our equation. Now it asks us, is this parabola, is our graph going to open up or down? The way we know if the parabola looks like a smiley face opening up, or if it's a downward face, a frowny face going down, is the leading coefficient. Sorry, there's something. Throat feels like it's okay. Sorry. The leading coefficient is the coefficient. Remember that coefficient is a number being multiplied to a variable. The leading coefficient is the number that's being multiplied to the term with the highest exponent. X squared is the term with the highest exponent. You see the power of 2. The coefficient is 1. We already saw that a was equal to 1. And it will open up if a is a positive number. So opens up if a is greater than 0. It'll open down if a is negative, so if a is less than 0. In this case, a is 1, so we know that it's going to open up. Knowing that it's opening up, and let's just arbitrarily draw a parabola that's opening up. This isn't the graph, but if My throat really hurts. Knowing that this is opening up, we can see that this is about where the vertex would be. Whenever we have a concave up, a parabola that's opening up, that vertex down there is a minimum, right? That's the minimum point to which our graph will lie, and it's just going to go infinitely up and up because it's opening up, infinitely up. But the vertex down here is at its minimum point for the graph. So when you have a graph that is opening up, your vertex is a minimum. If we had a graph that had been opening down like a frowny face because we had a negative leading coefficient, as in a was less than 0, this vertex is a maximum. That's the maximum point of which our graph will lie on our graph here. So to find our y-intercept, each of these different forms, the standard form, vertex form, and factored form, all of these different forms give some information already. The standard form tells us the y-intercept. Remembering that to be an intercept means that, in this case, a y-intercept, we're asking ourselves, at what point will our parabola cross this y-axis? So we're saying that's the y-intercept. What point will our parabola, when we graph our equation, will the graph hit the y-axis? To find out, the y-coordinate could be anything. It could be -18, it could be +6. We don't know yet, but we do know that the x value of the y-intercept is 0. So the x value of our y-intercept coordinate is 0. So we already know that so much. We're going to write our coordinate 0, something is that y-intercept. So what we have to find is, let's evaluate our expression for x equals 0. So we're going to evaluate equation for x equals 0. So here's our equation. Y equals x squared add 4x minus 12. When I put 0 in for x, that's y equals 0 squared plus 4 times 0 minus 12. Well, there is a shorthand way. I just want us to look at this together anyway. Y equals 0 squared is 0. 4 times 0, anything times 0 is 0. So we have 0 add 0, subtract 12. The shorthand way to know what the y-intercept is when we have a standard form equation like we do for number 4 here, it's the c value. This c value here is the y-intercept. So, c value is the y-intercept. So our y-intercept is at 0, -12. Let's go ahead and plot that point on our graph. 0, -12 is right down, right down, it's really hard to draw on this. Okay, that's a good enough. There's our y-intercept. Okay, to find the axis of symmetry, when we're given standard form, we're going to want to use that equation. Let me grab another color, maybe this blue, to find our axis of symmetry. Let's bring that down here. We're going to use the equation axis of symmetry. So x is equal to -b over 2a. That's going to be the axis of symmetry. Remember that the axis of symmetry is a broken line, so kind of like a dotted line that is vertical, so it's going up and down, and it is the symmetrical line of which the parabola reflects over. So it'll look better when we start drawing it out, but let's just figure out what x equals negative b over 2a. And we already identified what a, b, and c are up there. So x is going to be equal to negative b. If b right now equals 4, negative b is negative 4. So I'm going to write negative 4 divided by 2 times a. 2 times our a, which is 1, so 2 times 1. That's negative 4 divided by 2 times 1 is 2. So negative 4 divided by 2 is negative 2. So I'm going to go ahead and draw that line of our axis of symmetry where x equals negative 2. Remember that this is a vertical line. So there it is. No matter what the y value is, it doesn't matter, x equals 2. That's our axis of symmetry. That means our parabola is going to symmetrically reflect over the axis of symmetry. So x equals negative 2. All right, the last bit is to find the vertex. Now, the vertex is directly related to the axis of symmetry. So that's why we found that axis of symmetry first, because remember that our vertex is going to be a minimum point. So somehow our graph is going to look something like that. We don't know exactly what it's going to look like yet. It'll look something like that because we're going to have a minimum point for our vertex since it's opening up. So to find the vertex, we know that the vertex lies on the axis of symmetry. That is, the minimum point of our parabola, our vertex, is going to lie on that axis of symmetry. So we know that the x-coordinate, remember when we write coordinates, we write x first and then y. We know that the x-coordinate is going to be on the axis of symmetry, so I'm going to plug in negative 2 for the vertex x-coordinate. And now, to finish out what we're going to do, let's use maybe red. For our vertex, let's go up here. To find our vertex, all right. What we're going to do is we're going to evaluate, let's write that, evaluate equation for evaluate equation for x at axis of symmetry. I don't know if that'll make sense, but I hope that is clear. At the axis of symmetry. So what we're going to do is find, in this case, x is equal to negative 2. So in our equation, y equals x squared, add 4x minus 12. We're going to plug in negative 2 for wherever we see x. So y is equal to, instead of x squared, I'm going to write negative 2 squared, add 4 times negative 2, instead of 4 times x, subtract 12. And now we're going to use PEMDAS and algebra skills to finish solving out this. I'm going to do the parenthesis first of my exponent, negative 2 squared. Negative 2 times negative 2 is a positive 4. 4 times negative 2 is negative 8. So this is negative 8. But instead of writing add negative 8, I'm going to write subtract 8 because adding a positive is, adding a negative is the same thing as subtracting a positive. So I'm going to write 4, subtract 8, and then the last bit was subtract 12. Y is equal to 4 subtract 8 is negative 4. Negative 4 subtract 12. Y is equal to negative 16. So our vertex is at, I'll write it over here, is at negative 2 comma negative 16. All right. That's a different color. Oh gosh. Everything's messed up. There we go. Negative 16. So negative 2 comma negative 16. Let's go ahead and plot that on our graph as well. We'll use the green. So a negative 2 on our axis of symmetry, no surprise there, comma negative 16 for that y value. All right, one other thing that the axis of symmetry helps us with is I know the corresponding coordinate that is reflected across this one right here. So we have, here we have 0 comma negative 12. If I know that this axis of symmetry is where the reflection of my graph is created, I already know what the coordinate is on this side. That's going to correspond to the symmetrical point of our y-intercept at 0 comma negative 12. The way I'm going to find that is, well, what is the distance right here between our y-intercept and the axis of symmetry? That's 2 units. So I'm going to look for 2 units over to the left of my axis of symmetry, and that's where I'm going to plot this point at negative 4 comma negative 12. You can see here that this distance is 2 units, just as this distance is 2 units. So we've been able to plot 3 points, and now we can just connect them. Oh, didn't go through the point. Okay. The last bit that they want us to answer is the domain and the range. Remember that the domain is a fancy word to say what are all the possible x values, so x values that we could evaluate our function at. And the range are what are all the possible y values that we could evaluate for. So what are all the possible x values that we could plug into our function and produce a real number? Well, the domain for all quadratic functions is going to be all real numbers. And that's always the same. So all real numbers. And the way to draw this symbolically looks like a double R, kind of like that. All real numbers is our domain for all possible x values. We can evaluate all of the numbers, but the range is limited by our vertex. Remember, if we have a minimum or a maximum, that's how we're going to decide if the range is y must be greater than or equal to a number, or y must be less than or equal to a number. Since our vertex is a minimum point, as in this point here is the lowest point our graph will ever reach along the y-axis at negative 16, that means the range must be y is greater than or equal to negative 16. We do have a y-coordinate where it is negative 16. That's why it's equal to, but it also has to be greater than. So it's greater than or equal to negative 16. It'll never be negative 16 and a half. It'll never be negative 20. That's the lowest point. That's the minimum point on the y-axis that our graph will ever cross. So that's how we discern what the range is. Okay, our next topic is topic 2, graphing quadratic functions from factored form equation. Okay, here is the factored form. We know it's factored form because we have our factors in our parentheses. Is it going to open up or down? Well, we have to ask, what is the leading coefficient? Is the leading coefficient positive or negative? In this case, we have a negative leading coefficient. You see that negative 1/2 in front? So that means that our graph is going to open down. It's going to be something like that. And knowing that it's going to be a frowny face, we know if the vertex is a maximum point or a minimum point. And we can see there's its maximum. I mean, not its real maximum, but any graph that's opening down, any parabola that's opening down, because the leading coefficient is negative, is going to have a maximum vertex. Okay, now remember before how in the standard form, it was super easy to find the y-intercept, it was just the c value? Well, in factored form, it's really easy to find the x-intercepts. So to find the x-intercepts, to be an x-intercept, that's when the graph is going to cross our x-axis. Any of these points on the x-axis has a y value of 0. So we know that the coordinates are going to be some number for x, comma, 0. That the y value is going to be 0. So let's see what we can do to evaluate our expression. So for x-intercepts, solve for y equals 0. We're going to set our equation equal to 0 and solve for x, because these are the unknowns. We don't know what those x values are for that x-intercept. So we're going to set our equation. Here's our equation. Y equals negative 1/2 times x minus 4 times x minus 8. And like I said, we're going to set our equation equal to 0. So plug in 0 for y. 0 equals negative 1/2 times x minus 4 times x minus 8. Okay. The easy trick about this is we have to remember what the zero product property is, and that is anything times 0 will produce 0. So imagine as if this was like negative 1/2 times a times b, where that's a and that's b. What's in the parenthesis? X minus 4 is a and x minus 8 represents b. If a was equal to 0, so if a was equal to 0, here's 0, the whole expression becomes equal to 0 because there's multiplication between each of these terms. Multiplication happening between each of those. So anything times 0 will produce 0. So we want to set a or b equal to 0, as in what could make this parenthesis 0 to make the whole expression true and equal to 0, or what could make this parenthesis 0 for x and make the whole expression equal to 0. So what we have to do is set each of those parenthesis sets equal to 0. X minus 4 equals 0. X minus 8 equals 0. And solve for x. To undo the subtraction between the x and the 4, we're going to use the opposite operation, which would be addition. We're going to add 4 to both sides and see that x equals 4. On this side, we're going to add 8 to both sides to cancel out that 8 on the left and get x alone. Isolate our variable x to see that x is equal to 8. So if we plugged in this 4 for x into our equation here, we would see that, well, here, 4 subtract 4 makes this 0, and the whole expression is 0. That's enough for us to know. Same thing right here, x minus 8. If I put 8 in here for x, 8 minus 8 makes this parenthesis equal to 0, and the whole expression becomes 0, because 0 times, doesn't matter what this is, 0 times anything else will produce the 0 on the other equal sign. Okay. So those are our x-intercepts. We have 4, 0, and we have 8, 0. Sorry, I don't like how that looked. 4, 0, oh, 8, 0. I'm going to go ahead and plot those points on our graph. Here's 4, 0, 8, 0. Okay, to find the axis of symmetry now, since we've graphed 2 coordinate points, our 2 x-intercepts, we can now actually find the axis of symmetry just by looking at our graph. we have those 2 points, and the axis of symmetry is going to be the vertical line, the up and down line, kind of like the y-axis, the up and down line that's going to be equally distanced from each of those points. So if you're following along, you could probably guess it's going to be right there at x equals positive 6. You can see that because from, let's see, 4 to 6 on this x-axis, that's 2 units. From 6 to 8, that's also 2 units. That's how I know that's the axis of symmetry. It's going to be equally distant from the 2 coordinate points that are on the same axis. They're both on x, so that's why that's the axis of symmetry. Okay, hope like that made sense. And remember, we use the axis of symmetry to evaluate for the vertex. So I'm going to plug in 6 for the value of our vertex x coordinate, and now we just need to find the y value. So let's change our color, maybe pink. So for the vertex, I said it before, we're going to evaluate axis of symmetry. Axis of symmetry x value and solve for y. So here's our equation. Y equals negative 1/2 x minus 4 times x minus 8. Okay. And in this case, our axis of symmetry is x equals 6. So wherever we see x in that equation, we're going to substitute 6 and solve for y. Y equals 6. Okay, so y equals negative 1/2 times, instead of x, we're going to substitute in 6. 6 subtract 4. And here again, we're also going to substitute 6, subtract 8, and we're going to solve. Y equals negative 1/2. 6 take away 4 is 2. 6 take away 8 is negative 2. All right, we have some negatives involved. So negative 1/2 times 2 is negative 1 times negative 2. Remember that 2 negatives multiplied together produce a positive, so y equals 2. Our vertex is at 6, 2. Remember, we knew it was going to lie on the axis of symmetry. That's why I plugged in 6 for the x value. So 6, 2 is right there. And the last bit is just to connect our points. Oh, that's kind of really faint. Okay. Not a good one. Nope, still not a good one. Okay. All right. There's our graph. Also, the domain, as before, the domain is all real numbers. All real numbers. Oh, my goodness. Okay. Remember, that looks like a double R, sort of. And the range, as the range is directly limited by the vertex. We have a maximum vertex because our graph is opening down. If we have a maximum vertex, that means that y is going to be less than or equal to the y value of our vertex, in this case 2. That is, our graph will get no greater for a y coordinate than 2. That's the maximum y value that our graph, this equation, will ever produce. All right, moving on, topic 3. Graphing quadratic equation, graphing a quadratic function from vertex form equation. So this is vertex form. There is one parenthesis set. It is squared right there, and there's something happening after. The general form of vertex form, okay. So let's write that actually. Vertex form, different color, orange. Vertex form, y is equal to a times x minus, I gotta make sure before I say this out loud. I think it's minus. Yeah, okay, x minus h squared, add k. So this is like the standard form. If there's like something else happening, let's say there was addition here and subtraction there, that's okay. But what this tells us, this h and k, is the vertex. H comma k is the vertex. So as you could probably guess, vertex form gives us the vertex. So what I was trying to say though is, let's say we had, this is just a different example. Let's say we had y equals 2x add 3 squared subtract 4. This is still vertex form, but you see how in the regular form for vertex, there's subtraction between the x and the h, and then addition for the k. Here we have addition between x and the h, and subtraction on the outside. That would mean that the vertex for this problem would be -3, -4. But in this problem, number 2, which I think I'm going to need more space. No. I did not mean to do that. Sorry. In this problem, sorry, I still need more space though. Okay. In this problem, our vertex is at, let's write that here. Our vertex, and I can also, oh my goodness. Our vertex is at 2, 1. In this case, they're positive because it's following the expectation that there's subtraction between our x term and addition with our k term. Here's the subtraction inside the parenthesis, just like it is here, x subtract h. So if there's subtraction in the parenthesis, your h or your x coordinate is positive. But look here on my impromptu example, there was addition in the parenthesis with x. So if there's addition, but the regular form says there's subtraction, that must mean it is like x subtract -3 inside that parenthesis. But they don't write double negative like that. They write x add 3 because subtracting negatives is adding positives, and that's just a shorter way to write that. But we have to, and instead of add k, it would be add -4. And we don't write add -4 because there's a simpler way to write that. We just write subtract 4. But that's how you might see a vertex form equation, and we have to then know, okay, that's actually a negative, or that's actually a positive. So that's why you have to remember what the vertex form is and then compare that to the equation that you have. Okay, I did want to explain that. Glad I did. Okay, let me erase some of my work here. Okay, so we found our vertex. Let's go ahead and graph that at 2, 1. So 2, 1. There's the vertex. It doesn't ask us and it doesn't prompt us with everything. Is this a minimum or a maximum? This vertex here is going to be, well, what do you think? No one's gonna answer. This vertex is gonna be a minimum. Minimum. Reason why it's a minimum is because we're opening up. Opens up. The reason why it's opening up is because our leading coefficient is positive. So we know it's going to be something like that. We also know what the axis of symmetry is. Let's go ahead and write that. Axis of symmetry. Remember that the axis of symmetry is related to where the vertex is. So x equals 2. It's the x coordinate of our vertex. I'm going to go ahead and draw that. There's that axis of symmetry. Okay, what else do we need to do? Well, I guess we could find the y-intercept. So let's change up our color. To find our y-intercept, remember that's where the x value is 0, right? Because to be on this y-axis, we don't know what the y value is of the coordinate, but we know that the x value of our coordinate on the y-intercept is 0. So that's going to be solve for y when x equals 0. So we're going to solve for y. We don't know what y is. Here's our equation. Y equals 2 times the quantity of x minus 2 squared, add 1. So wherever I see x, I'm going to plug in 0, and I'm going to evaluate for y. Y equals 2 times 0 subtract 2 squared, add 1. Y equals 2 times 0 subtract 2 is negative 2. We're going to square that, add 1. Y equals 2 times negative 2 squared. Negative 2 times negative 2 is 4. Add 1. 2 times 4 is 8. Add 1. So y equals 9. So our y-intercept for this problem would be 0, 9. I'm going to go ahead and plot that at 0, 9 way up there. And we know the symmetrical point on the other side, on the right side of our axis of symmetry. So if there are 2 units here between our axis of symmetry and our y-intercept, 2 units to the right of the axis of symmetry would be 4, 9. So we also know that point. Okay, I think we have enough points to graph. We're just going to connect everything from our vertex, opening up, going up and up and up to our axis, to our y-intercept over there, and that's it. This graph actually has no x-intercepts because, let's talk about the, let's write it right here. Remember, domain is going to be all real numbers, and range. Remember that the range is related to the vertex. In this case, since we have a graph opening up, y must be greater than or equal to the y value of our vertex, in this case, 1. So the graph is never going to actually hit our x-axis. There are no x-intercepts. All right, that was topic 3. Moving on to topic 4. I actually had too much space. I can delete some of that. Sorry. Okay, topic 4. Writing an equation from a graph. So we have 2 graphs here, and we need to write the equation of the parabolas below in factored form. So find the zeros, the roots, or the x-intercepts. Let's start there. Plug the zeros into the factored form. Actually, I'm going to keep reading. Use the y-intercept to find the value of a in the factored form. Find the axis of symmetry using the roots, and then find the vertex. So many steps. Okay. Excuse me, momentary. Okay, so first step, finding those zeros, aka roots, also known as x-intercepts. I zoomed in so you can see exactly where our graph is crossing the the x-axis, as we're looking for x-intercepts first. So we're doing A first. I see here and here. That's where it's crossing the x-axis. So let's write those out. This is right here. That one is -2, 0. And that one is 3, 0. Okay. To write that in the factored form, remembering that, let me go back up to our factored form up here so we can compare. When we wrote it in factored form, do you see how here it's x subtract 4 and x subtract 8, yet it hits the graph at +4 and +8 because we have to evaluate for x being equal to 0. It basically flipped, right? It's the +4 subtract the 4 in the parentheses that made it that. So when we look at this problem, if it's at -2, if it's at -2, that's going to be x add 2. So for this one, it's going to be, let's use black, x add, oh shoot. Or I guess you can say x subtract -2, remembering that, and this one will be x subtract 3. Because when we evaluate for x, remember how we had to say, okay, what could make this parenthesis equal to 0? Well, -2 subtract -2 is equal to 0. And over here, if we put in this 3 subtract 3 is equal to 0. Okay, hope that makes sense. So we did that first part, we did A. Plug the zeros into the factored form. That's what we just did for B. Use the y-intercept to find the value of A in the factored form. Okay. So the y-intercept here, oh no, what did I just do? Shoot. I don't know what was in red, but the y-intercept is going to be right there. That's our y-intercept. Remember, it's where the graph crosses the y-axis. So that would be 0, 6. All right. And now what they're telling us to do is use that y-intercept to find this missing value of A, our leading coefficient, in factored form. So knowing that, what I'm going to do is I'm going to use this y-intercept coordinate. So 6 is equal, or sorry. I'm going to write the equation again. Y equals A, which is what we're going to solve for, times X. Oh my gosh. X subtract -2. And X subtract -2 is the same thing as X add 2. So I'm going to write it like that. X subtract 3. Okay. What we're going to do is we're going to use this y-intercept and plug it in. Use that coordinate and plug it into our equation here to solve for A. So instead of y, I'm going to write 6 is equal to A, which is what we're going to solve for, times, instead of X, I'm going to write 0, add 2, and then 0, subtract 3. Okay. You could use any points. You could use the x intercepts if you wanted to, but I don't know. It told us to do it this way, so 6 equals A times 0 add 2 is 2. 0 subtract 3 is negative 3. 6 is equal to A times 2 times negative 3 is negative 6. So I'm actually going to flip that because we always write the number first as a coefficient. Negative 6A. Last bit is to solve for A. So that means we're going to divide both sides by 6. And I need more room. Divide both sides by 6 to find that. Oh, no. Sorry. Divide both sides by negative 6 because we want A to be alone and we want A totally isolated, no negative in front of it. So both sides divide by negative 6. 6 divided by negative 6 is negative 1 is equal. Negative 6 over negative 6 is 1. So now we have A is equal to negative 1. And that's what I'm going to plug in here, negative 1. Okay. We also knew that A was going to be negative because we have a graph that's opening downward. Okay. Find the axis of symmetry using the roots. Remember that the axis of symmetry is going to be equally distanced between our roots. So here's the roots. Here's our x-intercepts. The distance between negative 2 and positive 3. Let's see, we have 1, 2, 3, 4, 5. 5 units. So that means that I need to split 5 in half. Half of 5 is 2.5. So 2.5 this way, and then 2.5 that way. Here's the axis of symmetry at 0.5. Oh gosh. Let me erase that. There's our axis of symmetry. Okay, and that means that the vertex, okay, wait, I'll write that. Oh, actually, I'll write it down here. Axis of symmetry. Oh my gosh, no, close. Okay, that means our axis of symmetry, x equals 1/2, which is the same thing as 0.5. You can choose if you like decimals or fractions better, same thing. And to find the vertex, remember we just evaluate our expression for that x variable, that x coordinate. So let's see, let's do, I think I need more colors. Pink again? Okay. So for the vertex, oh my god. We're gonna say x is equal to 1/2, and we're gonna evaluate for y. So our equation is y equals negative 1 times x, subtract negative 2, add 2, whatever you want to write. I'm going to write add 2 because that's, more standard. X subtract 3. Okay, so I'm going to plug in 1/2 for wherever I see x, and I'm going to solve for y. Y equals negative 1 times 1/2 add 2 times 1/2 subtract 3. Okay, y equals negative 1. 2 add 1/2 is, I'm going to write it in decimal now, 2.5. 1/2 subtract 3. That's negative 2.5. Negative 2.5. Okay, so we have negative 1 times 2.5 times negative 2.5. This is going to be a positive number because we already have two negatives being multiplied together. That's going to be positive 6.25. So that's our vertex, 0.5, comma 6.25. Okay, and you can kind of see that, how right here, the maximum point of our vertex right here is a little above 6. Okay, that's that. I'm not going to do the other one because essentially it's the same thing, the same steps, it's just a different graph. Last topic is topic 5. Okay, a word problem. So sometimes word problems are tricky because you have to draw it yourself and you have to infer all of this information. Well, let's just break it down. An apple is launched directly upward at 64 feet per second from a platform 80 feet high. The equation for this apple's height, h, at time t seconds after launch is h equals negative 16 t squared plus 64t plus 80. Now remember, this is standard form, and when we have standard form, the c term, the last term, the one that has no variable being multiplied to it, is the y-intercept. And they told us that this is where it's being launched from, a platform at the height of 80 feet. So I'm going to go ahead and start drawing a little preliminary sketch for us. So here is going to be my graph. And since we're talking about height and time, we're only talking about positive. Here's h, here's t. We're only talking about positive height, positive time, because this is a word problem. We don't have negative time, we don't have negative height. So I'm only doing the first coordinate of a graph as opposed to like that. We're only focused right here because we're talking about positive height and time. And they told us, remember, x-intercept, sorry, not x-intercept, y-intercept is this term right here. So I'm going to go ahead and say, let's say this is 80 feet. Remember, 80 height is measured in feet. This is measured in seconds. So will let me write that? Seconds? Okay. So what's happening here is this apple is going to be launched upward. So I already know it's going to go up and then, oh gosh, it's ugly. Up and then down. Still don't like that one. Okay, good enough. There's the apple being launched upward at a 64 feet per second velocity, and then obviously it's going to drop down to the ground eventually. This right here is that y-intercept, which we already know is at 80 feet. That's where it's starting at a platform that high. They want us to find the maximum height. They want us to find this point here, which is our vertex. To find the vertex, let's find the axis of symmetry. Remember that the axis of symmetry, and we have standard form here. Oh my gosh, that's so ugly. We have standard form, so we can easily use the A, B, and C, axis of symmetry. Remember, x is equal to negative b over 2a. A is whatever is multiplied toward squared term. So a is, and it could be positive or negative. In this case, it's negative 16. B is multiplied to our t term, or our power of 1. That's 64. C is 80, which we use to find the y-intercept. We're using the axis of symmetry formula to find the vertex. So in this case, x is equal to negative b. Negative b is negative 64 because b is 64. 2 times a, well, 2 times negative 16 for a. Negative 64 divided by negative 32. Well, negative divided by negative is positive, and 64 divided by 32 is 2. So we have a positive 2 for our axis of symmetry. To find the vertex, we then plug that in, right? We plug it in, our x value for the function. So let's do that maybe right here to find our vertex. Remember, we plug x from axis of symmetry, solve for y. So here's our equation. In this case, it's solve for h and t, but you know what I'm talking about. H is equal to negative 16t squared, add 64t, add 80. So we're going to plug in 2 for t. So in this case, t equals 2. That's the axis of symmetry. Why don't I go ahead and graph that first? I won't draw a 2. Why not? Okay. So this vertex right here, that's not exactly where the vertex is. This vertex is going to lie on this axis of symmetry where x equals 2. That is right down here. That's equal to 2t, or time is at 2 seconds. So the apple is going to reach its maximum height at 2 seconds. Let's find out what that maximum height is. So h is equal to, instead of t, we're going to substitute 2. Negative 16 times 2 squared, add 64 times 2, add 80. Okay, keep solving away. H is equal to negative 16, 2 squared, 2 times 2 is 4. Add 64 times 2 is 128. Add 80. Oh, okay. H is equal to negative 16 times 4. That's going to be a negative number, and that's negative 64. Negative times a positive is a negative. Negative 64, add 128, add 80. Negative 64 add positive 128 is positive 64. 64 add 80 is 144. So that height is 144, what is it, feet? So the vertex, and let's just write that, vertex, oh my gosh, no. So vertex, is at 2 seconds and 144 feet. So that's that point up here. That's 2, 144 feet. Okay, how many seconds will it take for the apple to reach the ground? They're asking us for the x-intercepts. There's going to be 2 x-intercepts because this graph would actually continue out looking like this. It would go down this way and hit the graph in the negative time seconds. But like I said, we're talking about time and height, so we only care about the positive values. So I'm only going to care about this right here. After how many seconds will it reach the ground? So let's go ahead and find those x-intercepts. To find the x-intercepts, well, we could, okay, there's a couple ways we could do this. We could factor the greatest common factor from our equation, which would be negative 16. And then we could use our normal factoring methods. We could use quadratic formula, which is always a trusted way to solve for x-intercepts / roots / solutions. We could factor it. I'm going to go through quadratic formula because I think that is the most important thing for you to know how to do because it'll always give you the right answer and it's very easy to use once you know how to use it. Okay, so let's do that. Quadratic formula. We've done this before, so if you know how to use the quadratic formula, you can stop listening. Quadratic formula. Remember, that is x, in this case t, but you know this, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And we already identified what a, b, and c are. That's right there. So I'm going to take those values of a, b, and c and start plugging in. X, which we're actually talking about t in this case because it's time, so maybe I should write that. T is equal negative b. B is 64, so negative b is negative 64. Plus or minus the square root of b squared, 64 squared, minus 4 times a, which is negative 16, times c, which is 80. These are going to be some big, big numbers. All over 2 times a, 2 times negative 16. All right, t is equal to negative 64 plus or minus the square root of 64 squared is 4096. Okay, this right here can get tricky because there's subtraction between 4ac and b squared, but there's also sometimes negative numbers. So 4 times negative 16 is negative 64 times 80. So what's happening here is there's subtracting negative 5,120. And as a reminder, we said this before, subtracting negatives is the same thing as adding. So I'm going to remove the double negatives and write addition between those two numbers. All over 2 times negative 16, negative 32. T is equal to negative 64 plus or minus, let's do that addition, 5,120 plus 4096 is 9,216. All over negative 32. Okay, what is the square root of 9,216? Let's find out. Take that square root. It's 96. Okay. So we have t is equal to negative 64 plus or minus 96 all over negative 32. Now remember, to find the value of t, because there's going to be 2, we're going to split up our plus or minus sign and write 2 separate equations. So let's do that. We have t is equal to negative 64 plus 96 divided by negative 32. And t is equal to negative 64 minus 96 divided by negative 32. Okay, on the top, negative 64 add 96 is positive 32. Divide by negative 32. Well, a positive divided by a negative is a negative, and 32 divided by 32 is 1, so this is negative 1. But remember how I said time can't be a negative? So this one doesn't really matter to us. This isn't the right answer. Let's evaluate the bottom one. Negative 64 minus 96. That's negative 160 divided by negative 32. Now we have a negative divided by a negative, and that produces a positive, and 160 divided by 32 is a 5. So that's our answer. At 5 seconds, the apple will hit the ground. So this would be x-intercepts are at negative 1, 0, and 5, 0. But like I said, this is the only one that we care about because we can't have negative time, right? Can't have negative time. Okay, So when we go back up here, how many seconds will it take for the apple to reach the ground? Our answer is 5 seconds. And that's this point here. That would be 5, 0 at 5 seconds. Okay, so as we have done in this call, a bunch of different kinds of graphing problems, and that is all I have for you. It's really dark now, so bye. Thanks for watching.